Hello, everyone. This week, besides the last design patterns, we're going to be covering some topics that I injected into the software architecture class because of my research in the security area. So I always wanted to teach in a software architecture class students how to do secure coding. So this is the goal of this set of lectures. Um, you may not use it nearly as much in your Fitbit project. We use it much more when I do a different project and election software. But you may want to, let's say, encrypt some data to protect some sensitive personal information and things like that. So it may be a nice feature and enhancement in the Fitbit software that you're designing. But even if you don't use this secure software development nearly as much in this specific project, it's paramountly important to know the principles of secure software development in order to be a better developer. So I'm going to give you in the beginning some motivation about why we develop secure software, and then we will look at the software development lifecycle, but in terms of security. So we're going to call this the secure software development lifecycle. And then we're going to look at some standards for secure software development, the OWASP standard and the SANS standards. I have a few slides here with some motivation of why we're learning secure software development. There are some really famous attacks that in 1998, for example, a malicious software took down the internet at the time, which was very few computers that were connected at the time. But issues like buffer overflow, which you may have seen if you're taking my security class or if you have taken that one, have been with us for a while. And because of the lack of awareness of developers, we haven't corrected those and we haven't been able to avoid this. So developing awareness through this class and learning and understanding how to make our code more secure is going to be a big and very important part of this set of lectures. There are sites, federal and private industry and academic, that keep track of vulnerabilities and specifically software vulnerabilities. And one of those is the Common Vulnerabilities and Exposures site, CVE. .mitre.org, and I would encourage you to go there and check this out and browse it and look up things with the words buffer overflow, which is an attack where you can inject malicious code to somebody's code because they don't sanitize their input, because they don't check input, or because they use unsafe utilities. And so this attack has been with us, as I said before, for some time. It's an old attack, but we still haven't found ways to completely resolve this. And the biggest thing is that coders' awareness needs to get to the level of avoiding buffer overflows and diligently checking for issues like these. Now, during this class, we've been discussing a lot about the development life cycle, and we have looked at different phases of that through the unified process framework. Here there is a recap of this development lifecycle where we start with investigating the visions, we call this, and then we analyze, we create designs, logical and physical designs, implementation, and maintenance. And what we will be discussing in this lecture is how do we embed security in that software lifecycle. towards the secure development lifecycle embeds security from the beginning, from the vision of a software project until the end, until shipping and maintaining. So it's really deeply ingrained. Security is not an afterthought. It's truly a continuously integrated into the software lifecycle. Initial steps of investigation and developing a vision and all that, one can integrate enterprise information security policies in the investigation and the vision of a project, so that there are policies and processes whenever there's an issue, like, for example, private data handling, transportation of data, and issues of availability and confidentiality and integrity of the data. The thought is with the developers, and there is a policy to guide them from the very beginning of the software lifecycle, the investigation phase. Then during the analysis phase, risk management tasks may begin, and we even discussed this in the unified process, that during the development of the vision and when we are analyzing whether we should do a software project, implement a software project or not, we need to evaluate how risky it is and have a risk management plan. Again, this is an easy step that can be integrated in the software lifecycle and develop software with integrated security. Logical design of a project, a developer that is security aware thinks about business continuity, and if there's catastrophic loss of data or connection or something along those lines, their software can take care of this, and there is a process, and there's a guidance on how to take care of anything catastrophic that may happen to the software and help it continue functioning at some level or another. Physical design, where servers may be needed and other infrastructure may need to be purchased for the software to operate. One needs to evaluate the technology, again, with security in mind, and determine how ready is the organization to integrate the software and have it run in a secure manner. As we are implementing and, of course, shipping and testing, security needs to be in the mind of the developer, and continuous testing and integration, black box testing, white box testing, as we've discussed before, is a way of assuring the security of the product. The fact that it may have properly checked input, so that the adversary cannot create buffer overflows and execute malicious code, so that it has sanitized inputs, so that it has continuous integration and continuation of its operation, and availability and integrity of the data, and of course confidentiality of the data that it's handling. So it's really paramount to have security in mind during implementation and, of course, testing. As I mentioned before, testing is an integral process that helps us guarantee the security of our software. Good, robust, thorough, detailed testing can help us predict the behavior of an adversary and avoid it or manage it appropriately. And of course, testing and maintenance can help us keep improving the continuous improval of the security of a software product. Very important set of resources is the Open Web Application Security Project, OWASP. The OWASP project is an open source project by professionals, developers from the industry, and it has a fantastic list of top 10s. It started just for web applications, but now there's top 10 for secure Android software development, for IoTs, and you name it. So I strongly encourage you to visit this website. And when you're in a team that you have to integrate security into your software, and not just as a non-functional requirement and an afterthought, but continuous integration of security, that's a fantastic guide, standardized guide to use. And here you can see how OWASP approaches the software development lifecycle, assessing, setting targets, defining the plan, implementing and rolling out a secure software using this secure software lifecycle. Another set of standards was created by the SANS organization. This is a federal slash industry type of organization that has been doing security for the past 25, 30 years, MITRE and SANS. And they have a great guide for the top 25 issues that you need to take into account when you're trying to develop your software as securely as possible.